This, I just thought I'd go through the assignment and how I would go about aligning this example and kind of walk you through my thought process, how I go about doing it, and maybe also introduce you to a few different features in the app that maybe you haven't come across. But if there are any questions, just ask in the Q&A and I can answer as I go along. So the first thing that I do probably after loading in is to assess the different electrophysiology plots. So basically just to toggle through them. So if you look in the display options, there are these different shortcuts that allow you to toggle through the different plots. So in this case on Mac, it's like option 1 or option 2 to toggle through these. So what I do is just kind of toggle through them, get a feel of how the data looks. So now the image plots, the amplitude plot takes a little bit of time to load. There's many dots that it's displaying. But you can see there. And just get a feel for how the data looks. So we can see we have this very high kind of distinctive power spectral density in the LFP band, and also these bands like in the clusters. So looking at the data, I think the first plot that I'm going to use is actually this amplitude plot. That takes a little bit of time to load. Yeah, and the thing that I noticed first is that we have these clear kind of white bands. And if I look at the histology, I see I have hippocampus and then some fiber tracts and also these molecular layers that I was referring to yesterday. And then beneath that, we have the thalamus. So what I immediately see is that this layer here around 2000 is probably the boundary between the thalamus and the hippocampus. So what I'm going to do is just click on it, add these reference lines, move them up to where I think they should match, and then apply this fit. Yeah, so then the next thing, carry on looking through the plots. So I see that there's this high firing rate area here as well in this line plot. And this normally corresponds to a pyramidal cell layer, so layer in the hippocampus. So I see I have CA1 here, so I think I'll add another reference line that just passes through there and apply a fit. So in this case, we've now, applied an offset and also a slight scaling in this region here. Yeah, I think to be honest, that's about for this example. I think I might just use these two reference lines as my fit. And once I'm happy with that, I'm going to hit upload and save the channels. And what happens when you save the channels is in the file where you had all of your data present, you should get this new file called channel locations.json. So if you open that up, it's basically a JSON file where it's a dictionary, where for each channel you have a new XYZ coordinate. So these are relative to Bregma, kind of the location where this channel is along your probe, and also the brain region that's been assigned. So when you then want to use the output from this GUI in your analysis, you can read in this file and then have your new brain region annotations. Another thing I want to mention is that, so once we've saved our alignments, you see that we've updated this drop-down menu here. And this basically means you can reload the GUI using the lines that you've kind of saved in one case. But if, for example, you want to overwrite your alignment, you can go back to original, get data again, and it will load the GUI up in this like clean state where you don't have any alignments, and you can realign and add these reference lines, and it will basically overwrite the data that you have. Another thing to point out is there's this save plots button. So if you click this, what it's going to do is basically iterate through all of the images in the GUI and save them locally on your computer. So in your file where you have your data, you should get this new folder called GUI plots. And so you see all of these individual PNG files, but there's one called overview, which you can open. And it just gives you a snapshot of all the displays that are in this GUI. So sometimes it's quite useful to get this and you can look at it offline and just get a feel of how your data looks. Yeah, some other features are, so here in this example here, I just used all units. So these are both the ones that have been labeled good and bad. But there's also the option to filter your units. So in this case, I can filter by either the outputs by kilosort that were automatically given, and perhaps with Julie, we could talk about maybe incorporating some of the bomb cell metrics in here. But at the moment, you can filter for IBL good, for example, and it will reload all of the plots, but only showing the good units. So for the raw features, so the LFP and the AP, this won't make any difference, but particularly for these cluster views, it's going to change how you display the data quite significantly. So that's something you can also play around with. Yeah, I think that's about it. So I would say on this wiki that we have for the IBL apps, there's also a link here to some more example data. So there's different, I think there's like 2 or 3 different sample data sets. So you can also play around with that, and that will have all the data prepared and packaged for you, so you can get a feel of how to do other alignments. And I also want to show just this preparing your data for the GUI. So we have this file basically, or this method that you can import from the package called extract data. And what you need to do is basically pass in your path to your killer sort output or your spike sorting output, the path to your raw ethers data. So this is going to contain your spike GLX AP band data and also the LFP data. And then a pathway you want to save, and you can then just run this extract data and it will repackage all of the data that is required in order to read it into the GUI. And in terms of the histology data, so how to read in your tracks. So in this, we use kind of the reference frame of the IBL, which is slightly different from the Allen in that we use a bregma-centric reference point. So our 0 coordinate is at bregma. So we have some little code snippets that if you've used, for example, SharpTrack or AB histology or other tools in order to extract, and I guess also Brain Glue to extract your probe tracks, you can just use these little functions to convert from that coordinate system into the coordinate system required for the IBL. Yeah, thank you.